Hello friends, today we are going to see some easy tricks to solve integration. The first one is, if you find the integration of f dash x upon fx. What is this meaning? Suppose you have the given function in the denominator and its derivative in the numerator, that is f dash x upon fx. Then you can directly write down its integration as log f of x dx. Whatever may be the value in the denominator and its log, that is log f of x plus c. Now I have taken three examples here. Let us see first example, integration minus sin x upon 1 plus cos x dx. How you can understand that this example is of the type f dash x upon fx. So now consider 1 plus cos x is our f of x. I will make you understand it here. F of x is equal to 1 plus cos x. Okay, its derivative f dash x. Derivative of 1 is 0, derivative of cos x is minus sin x. So you can see here minus sin x is in the numerator. So it is of the type f dash x upon fx, where f of x is 1 plus cos x, its derivative minus sin x is in the numerator. So what is the answer? The answer is log f of x. F of x is 1 plus cos x. So you can directly write down its answer as log 1 plus cos x, log 1 plus cos x plus c. See here, our function f of x is 1 plus cos x, its derivative minus sin x. This example is of the form f dash x upon fx. So directly its derivative is log 1 plus cos x plus. Now let us move to the second example. Here also, if you can see x square plus x plus 3 as our function f of x, its derivative will be 2x plus the derivative of x is 1, the derivative of 3 is 0. So simply its derivative is 2x plus 1, which is in the numerator. So again it is of the type f dash x upon fx, where fx is x square plus x plus 3, its derivative 2x plus 1 is in the numerator. So it is of the type f dash x upon fx. Its answer will be log f of x. So what will be the answer? Log x square plus x plus 3 plus c. So you can directly write down its answer as log x square plus x plus 3 and then plus integration constant c. Okay. Now in the last example, focus it here. The derivative of x square is 2x, the derivative of 1 is 0, but here it is x only. So don't get confused here. You have to involve x here. You have to mention, you have to write down x here. So how you can write it as 1 by 2 integration 2x. So if we multiply and divide with 2, then it will be 2x and 1 by 2 outside, 2x upon x square plus 1 dx. So if the given example is not directly in the form of f dash x upon fx, then you have to make some changes. Look at here. The derivative of x square is 2x, but since here x is only there, so multiply divide by 2 to get 2x here, the derivative of x square. The derivative of 1 is 0. So x square plus 1 is our f of x, its derivative 2x in the numerator. So it is of the type f dash x upon fx. So simply its answer is 1 by 2 log, what will be the answer of this is f of x is x square plus 1. So it is log x square plus 1 plus c. Now let us move to the second easy trick. If integration of f of x, see here, the formula is f of x raised to n into f dash x. So inside it is the function and outside it is derivative. Suppose here you will have sin x, then its derivative cos x will be outside. Okay, so the formula is to be understood like this. The function is inside, it's raised to n, where n is not equal to minus 1. n should not be equal to minus 1. That you need to assume. It can be any real number, but it should not be equal to minus 1. So f of x raised to n into f dash x, the function raised to n and into its derivative will give you the answer f of x raised to n plus 1 upon n plus 1. The function itself here raised to n plus 1 upon n plus 1 plus the constant of integration. Only one thing is to mention is n should not be equal to minus 1. Let me write down it here. So it will be easy for you. N should not be equal to minus 1. Okay. Now consider this 3 example. F of x sin x, its derivative outside cos x. So what will be the answer? N becomes n plus 1 and in the denominator n plus 1. So what can I write the answer here? The answer will be sin x raised to, it was 3. So 3 plus 1 is 4 divided by 4 plus the constant of integration c. Okay. Now in the second example, x square plus 2x plus 1, its derivative, the derivative of x square is 2x, the derivative of 2x, the derivative of x is 1. So x square's derivative 2x, the derivative of 2x is 2 plus 1, its derivative is 0. So simply compare with this, f of x raised to n plus 1 upon n plus 1. F of x is x square plus 2x plus 1. So the answer will be, what will be the answer? X square plus 2x plus 1 and its raised to 9 plus 1 is 10 upon 10 plus c. Clear? So whatever may be the function inside, its derivative should be outside and its raised to n, then the answer will be f of x raised to n plus 1 upon n plus 1 and plus the constant of integration. In the third example also, the derivative of log x is 1 upon x and 5 is in the numerator. So 5 plus 1, 6 upon 6. So answer will be log x raised to 5 plus 1 is 6 upon 6 plus the constant of integration c. And finally, let us take the third trick. If integration of small fx is, suppose say capital Fx. Okay, what is the integration of small fx? Let us see, it is capital F of x plus c, where you will have a constant of integration plus c. So I'll make you understand small f, capital F, don't confuse here. Suppose small f is sin x. Let us see here. Okay, suppose small f is sin x. Its integration is minus cos x. So small f is sin x, capital F is minus cos x. Okay, so small f, capital F, don't get confused. The integration of this function, suppose it is outside, this is capital Fx is integration of small fx. Okay, that is you need to understand. Integration of sin x is minus cos x plus c. So sin x is small f, minus cos x is our capital F. So if it is this, then what happens? If you want to find integration of small f ax plus b dx, it would be this a will come in the denominator 1 by a into this capital F ax plus b plus c. Okay, so x remains x here, and what happens here? Ax plus b remains ax plus b here, but its derivative, the derivative of ax plus b is a, that comes in the denominator 1 by a f of ax plus b plus c. Okay, so function, its integration is outside, function, its integration remains same. See, f of ax plus b remains f of ax plus b, same all these things, but the derivative of ax plus b, that you have to multiply with 1 by a into f of ax plus b. For example, I have taken the example of sin 3x plus 5. What will be the integration of sin 3x plus 5? This you can solve by the method of substitution also. Sin 3x plus 5, you can take it as t and solve it, okay, by the method of substitution also. But if you know this trick, you can directly solve it. Integration of sin x is minus cos x plus c. Then the integration of sin 3x plus 5 will be by this formula. A is 3, the coefficient of x is 3, so minus 1 by 3 cos 3x plus 5 plus c. Same simple example. Now we know the integration of tan x is log sec x. Integration of tan x is log sec x. So here tan 5x minus 9 will be, 5 is the coefficient of x, 1 by 5 log sec 5x minus 9 plus c. Simple examples are this. What about e raised to 7x plus 4? If it is e raised to 7x plus 4, then we know that the integration of e raised to x is e raised to x. Okay, so here e raised to 7x plus 4, the coefficient of x is 7, so it is 1 by 7. Just like the formula, f of ax plus b, 1 by a comes outside. So 7, 1 by 7 comes outside, e raised to 7x plus 4 as it is, plus c. Okay, so these are some simple tricks you can practice and solve it. It is also important that if you solve this, then in MCQs you will directly write down the answer. From 4 options you can directly find out the answer. Okay friends, thank you.